with labor, although I recognize its importance. And in fact, I put a dash up here, really because it's between fetal and infant that we aren't paying a lot of attention to, but we recognize if we don't have information about what went on during labor, we aren't going to be able to make the kind of predictions that you were just asking about and we were just hearing Martin talk about. And it'd be part of an important set of features for making those predictions. All of the antepartum measures I'm going to be talking about, we are biased, we think they're important, but we also think labor information has to go there. We also, I'm not even going to touch on the placenta, which is the mediator of all things, well, or many things, and that should be part of the equation. And then later, we aren't going to be predicting one outcome. So late, in fact, maybe in 2 years' time, Nicolo and my postdoc Lauren Shuffrey might be back where they are using machine learning, not just to gather the features together about what our heart rate variability and EEG measures, how they fit together, but also how the outcomes, different clusters of outcome that will pertain to different kinds of phenotypes. So I'm not going to talk about any of that, but I just did for my first minute. So I just also want to recognize that there's a few people in here, Hein Odendaal particularly from South Africa is responsible for 7,000 of the data points I'll be talking about here a little bit. I promise I won't go through all 7,000, but he was responsible for a lot of that. And my colleagues from now, we have this wonderful pipeline with Maristella Lucchini and Maria Signori and wherever you are, Nicola Pini, who really have helped us move the next step forward in understanding the signals that we have and what they mean. So, and I also will be talking about the fact that I do spend a lot of time going across this time period here, from fetal to this ex utero fetus to the young infant. And more recently, we've gone out to the geriatric age of 2 years of age, so I might mention that briefly. This is a quick outline, so you can plan your nap. I'm going to just quickly go over again our overview of what we think we're doing, our new methodologies for monitoring sleep and autonomic regulation, which we think are critically important, or I wouldn't be standing up here talking about them. But some of our ongoing and upcoming fetal and newborn studies, particularly the large data sets that we think may be useful to some, and then talking about those data sets, how there might be opportunities for collaborative efforts, at the very least, sharing our data with you to do the kinds of exciting things I've been hearing about today. So when I started this work, I started asking questions about newborn learning, how well they could learn about their world, what they learned in utero, for example, learning about their mother's voice, or the cadence of their language, or their mother's smells, etc., how we could ask questions of them. We needed a wide-awake creature to do that. And then we came to find out that they're spending more time, like my students spend, but also they're in this state a lot. And even more troublesome, they're in this state, which is very difficult to ask them questions. And some of them are just downright disagreeable, and they're not going to tell us anything at any time. Fortunately for us, this is where the lamppost is shining. Here and with the fetus, they are asleep, and they sleep a lot. So we have been able to figure out, based on work of others naturally that we built upon, that you can ask an awful lot of questions, meaningful questions about both the autonomic nervous system as well as learning and other things while creatures are asleep. This is, I'm only showing this graph only because it's something where I meant to put the reference down there. We're looking at about 4,000 or 3,000 maternal fetal dyads over gestation. This is just one of the several measures. Standard deviation of heart rate increases, as you might expect, across gestation. But what I really wanted you to reference is our colleagues here from Porto have done literally 10 times a better job. They have 10 times more subjects where they did this using CTG, and they've done it in ways where they've looked at all of the other important measures, particularly sex differences, that we have to think about. So I won't talk about that, but I will talk about a little bit about what we've done with characterizing physiological trajectories. I apologize for this being so small, but I'll see if I can walk you through it. This is showing that fetuses from 20 to 24 weeks, 28 to 32 weeks, and 34 to 38 weeks have these, as you know, marked changes in heart rate, a very systematic decrease in heart rate over gestation. This is by combining all sleep states together. We find the same things in almost every measure we have of heart rate variability, where you see an increase in variability over time. We also, one thing we did add is because of the CTG we used, there was a TOI2 monitor where we used a low-pass filter, which had been already validated by other folks to give us a nice movement signal, a reasonably good one, in fact, along with giving us a heart rate at the same time. We also saw changes in fetal movement, but we really didn't see increases until out here in the 34 to 38 weeks. And then things start changing, as you know, at the end of pregnancy, where you can get less movements. We want to do this, though, not just because we want to begin to sort of account for some of the changes in variability, but we also think another very useful autonomic measure is the coupling between fetal heart rate and movement. And this very systematically changes over gestation. And Janet DiPietro has written a lot about that, so I think you could even find more useful information going to her. What I also wanted to show, though, is that this is the data you just saw a moment ago. But if we go out to the late period where fetal states have begun to be more coalesced and integrated, 34 to 36 weeks, if you look at 1F, which is quiet sleep, 2F, active sleep, and 4F, what has been called awake. And again, there are many issues with using heart rate patterns to characterize state, and the Dutch have done a wonderful job, I think, with that. And I think they've published a lot on it, as you probably know. And I think there are now ways we can go, and maybe they are now too, I would think, going forward to use more of these automated cluster approaches to do a better job of what we think might be claiming what different sleep states are. We do that a lot because we study, as I mentioned, the ex utero fetus, the preterm infant, which has many of these same features, but then a few additional ones because, of course, they now have to breathe. So, and then also the same thing happens with fetal movement. Things change dramatically with sleep state from quiet sleep to active to awake. And then the same thing here for fetal heart rate movement coupling goes in the other direction. If you are trying to think that someday your grouping of different measures, different parameters, are going to be at all useful in helping to design a risk or design a certain phenotype, this is just saying if you don't pay attention to age and sleep state, you may miss the boat. And in fact, you can see that right here. If your value was up here, but it happened to be in quiet sleep, and yet you got a score down here, if all you did was quiet sleep or even these two sleep states, you come up with a very different perspective of what your measure may have meant. So also, just to show you, the same approach obviously works in the ex utero fetus, the late preterm baby. These are late preterm babies, average heart rate, so it's right within 2 days after they're born. These are early term babies who are born from 36 and 37, 37 and 38, and these are full term infants. You get these systematic changes by when you were born. This is a reflection of how well the autonomic nervous system has matured when you're born. It's very important. These preterm babies and late preterms have to face the same world. They have to deal with the same challenges, yet they aren't fully equipped for it. They haven't been in the oven long enough. We get these same measures in EEG, which I won't go into right now. And again, we have to make sure we look at these sleep state differences. Same things with overall variability. There are changes with sleep states. Some of them are more expressed in active sleep, where there's a lot more activity going on, obviously. These weren't significant, but they go in the same direction for quiet sleep. And then the measure of beat-to-beat variability, RMSSD, which Martin so nicely portrayed. There are many other ways we can go about doing this, but this is the one that is easiest to describe right now. And you see these distinct measures in this parasympathetic control, whether you're late preterm, early term, or term, in active and quiet sleep. Just to show you, we have other ways. We have about 4 of them, but I'm not going to go into them. But we do more than heart rate variability, and we do more than EEG. We have a non-invasive EEG that goes on in under 2 minutes. It's made from saline or put into these little sponges, and we're able to put it on. We have an EEG right there inside the newborn nursery. But we also ask questions of our kids. We happen to ask a question about learning during sleep, where we paired a tone with a puff of air that went gently to the eyelids when they were sound asleep. These babies would learn to not so much blink because their eyes were already closed, but if you kept pairing tone, puff, tone, puff, tone, puff, within 15 minutes, they started blinking to the tone alone, which they didn't blink to before. So they've learned to sound asleep, and it's the kind of thing where the vast majority of our full-term babies did this thing. It took about, again, 25 minutes. If we had a group at the same postnatal age of early term babies at 37 and 38, 75% of them learned. And if you took these late preterm babies from 35 to 36, again, using the same length of time, same stimulus, only 57% of them learned it. Now, some of them learned it. And again, if I put it on there, there'd be big error bars around there. But it's one of our other probes, being able to ask something about how babies perform. We do other EEG tasks where they have to listen to different tones and recognize that it changes even while they're asleep. But that's a topic for another discussion. I wanted to show you another risk group before I leave babies for a moment, where we're talking about infants born to mothers with gestational diabetes. All their measures, the parasympathetic, sympathetic control measures, the usual suspects, all change whether or not these are babies born to moms matched for everything else that did not have gestational diabetes and those that did. These are confidence intervals. All of these were significantly different based, again, whether these infants were born to moms without GDM or with GDM. And it's the kind of thing, we also see this at the first day of birth. We also are hypothesizing, because we've begun 2 different cohorts, one in South Africa and 3 now, one in New York and one in London, where we are looking at the fetuses of these mothers at the same time. And just to show you that, again, this can relate to other brain measures. I don't know how many of you know the VEP is a visual evoked potential. It's just flashes of light that occur every few seconds, and you give about a couple of hundred of these, and you can then measure the brain response, so the latency to a peak over the occipital cortex that occurs when you are sound asleep. And I think you can maybe see right here, this latency changes dramatically. It gets longer. It gets longer and longer by gestational age, which is up this way. So if you're near term, your latency is here, which is nice and short as it ought to be. But if you, as you get down here, younger and younger, and also with GDM, as it turns out, you have a much longer latency. Again, it's something we can do. That takes about 7 minutes. You know, back in the day, we used to be told when I started this, which was, yeah, a long, long time ago, they didn't even have hearing tests because, oh, that's too complicated. Your kids can't do it. Well, you can't go into a nursery in the States and most other places without now having an auditory brainstem test and or autoacoustic emission. Now now 2 fetuses, finally. We happen to use one of the devices for our first, somewhere in the neighborhood of 7,000 recordings using the Monica device, which worked really well for us, and the company was really helpful for us being able to use the raw data. It was also what we loved about it. I could do this in South Africa and other countries because you just had to pay for the sensors and stickers each time, and you could run a study for $3 or $4. And you could have access to the data. Those times have changed a little bit, but we're still looking for ways that we can go in and ask questions, including about fetal health, but even this one, the role of maternal sleep position, where we can send this home with moms and ask about what effects that has on the fetus. We can also get information about maternal position, not through this device, but using other ones. And we did one study where we only had 42, but now we've replicated with another 120, where we're able to look at fetuses and mothers overnight. This is just one example. You don't see too much of it, but I think it's clearly can be important, where this is representing a minute by minute. This is 6 hours of an overnight recording. This is fetal heart rate. And I think you can appreciate, without even having the statistics here, this is based on heart rate patterns that the Dutch use. This is quiet sleep. This is active sleep, quiet, active, active. This purple, which you can barely see, is designated awake state. But I think you can see a few things there. That if we're going to go in and use our favorite measures, this is just heart rate, but every single measure we use of heart rate variability shows distinct state differences. Not only that, they show a difference that can change over the course of the night. This isn't a huge circadian rhythm. It's not nearly as large. This is maternal heart rate, which can change quite dramatically over the night. We've had pulse rates where the mothers started at 80. By the end of the night, they're down in the 50s somewhere. And you just don't think about that with pregnant women. Well, in addition to that sort of information, we're not only getting the sleep state cycling. Here, we've referenced maternal sleep position. This ugly green color is when the mothers were supine. The red is when the mothers were on their right, and the blue when they're on their left. So we're able to document not just maternal changes. Oh, I took that slide out because it was taking too long. But also not as many fetal changes. We got a few, but part of why we didn't get a fetal change is because you have to have the same amount of data in the different sleep positions for each mother in order to get a repeated measure. And you add onto that fetal sleep state, which changes our numbers dramatically. So that was a little tricky. But we do care about sleep and HRV for some of the reasons you've already heard already. Heart rate variability is really a wonderful marker of neurodevelopmental health in a lot of different conditions, a lot of different trajectories. You can use heart rate variability to look at the effects of exposure. We've shown that alcohol prenatally and smoking prenatally, along with maternal depression, can change a newborn infant's and a fetus's heart rate variability. heart rate variability, yes, this measure of parasympathetic sympathetic control is clearly very important in attentional regulation as well as emotional regulation. Well, sleep functions in much the same way. Again, sleep is really the mediator of most of the things we care about. Again, effects of exposure, interventions, attention. If you want to make sure you can't remember what I'm talking about right now, don't have any sleep tonight. Well, you might not remember anyway, but that'll do you in. Emotional regulation, make sure you don't have sleep for a few nights in a row. And that expression of waking up on the wrong side of the bed clearly has some merit, and a lot of that has to do with how we aren't able to regulate our emotions if we don't sleep, right? Immune function. I mean, and again, everybody in this group probably already recognizes this, that if you want to have compromised immune function, make sure you don't get enough sleep. And we particularly notice that as we're trying to recover from some inflammatory event and don't get enough sleep and see what happens. This is the one that a lot of people tend to forget about. The only time we grow, we grew when we were younger, was during sleep. That's pretty much the only time. That's when growth hormone is released, and only typically during the second cycle of sleep. So I think for all those reasons, sleep, and then if you combine that with heart rate variability, we can start filling in some of these gaps. With women, we can get studies with pregnant women, more objective sleep measures that we can use for everyone. We can use in diverse populations. We have colleagues in New York who very much see a difference based on where you're living, what your socioeconomic circumstances are, the crowding index in your home, how many people are there, not just how many are in your bed, are going to affect how it is you sleep. And we obviously, many people are already thinking about connecting sleep and cardiovascular health. So, because why? Because you need a good night's sleep, trying to have all these things occur. Sleep complaints during pregnancy are among their highest, as again, many people in this room can attest to. And there's consequences of this poor sleep. We already know that there are relationships with many of these outcomes. These have been documented, many in epidemiological studies, but more and more in actually prospective studies, collecting all this information. So how do we get that, though, is the other thing. And this is where this explosion, not just a wave of wearable devices, it's a tsunami, and hopefully we can harness that power to be able to start getting these measures in non-invasive ways in the home. So right, that Monica device I showed, we took that one home. And we did now over 200 mothers and fetuses watching them sleep overnight. And so we can get through our other sensors exactly when they went to bed, how much time they were asleep, all these things. And again, we can get information. There are now apps out there to give you a lot of this information. Some apps will do this better than others. And then environmental apps. We can find out more about the sleep environment. All very easily done now. And in fact, we're part of a large study in the US for 50,000 babies, 35 different cohorts all over the states, where these data are now being collected in very feasible and ways that aren't both a burden to the subject and to the experimenter, because the researchers have to do a lot more when they get to this. This is just one belt. I just wanted to show you one. I'm going to show you 2 pictures. We're working with about 8 different wearables to try to figure these things out. But this is one that we're pretty happy with, that we use with the mothers to be able to get. This happens to just be a tracing of the ECG. You can get those dry electrodes inside here. You can get really nice EEG, and yes, it goes away when you have these periods of movement. It also records movement, so you know when you either lost signal or expect to have lost it. And there are gyroscopes in there to give you position at the same time. So we know what sleep position the mother is finding herself in. And the other good news about this, I'll bring it right in, this costs about 50 euros, maybe a little bit less, especially if you buy in bulk. I'm not suggesting it. I don't own stock in this company, but in our hands, it really works well. And in fact, our Finnish colleague, Sansa Vanhatalo, has put this belt, or little bits of it, inside the waistband of a pull-up nappy, so you can put it over the diaper that collects all the stuff you might not want, unless you're studying the microbiome. But we don't want that. Pull-up diaper, and this goes around the kids, that kid wears it all night long. It's especially helpful when you don't have to change nappies 3 times a night. So we're starting it. Oh, that was just my call that I have 10 minutes left. So as a reminder. And so anyway, this thing, now we're starting to use it now with Maristelle Lucchini is leading the charge on this. So we're starting as young as 6 months. Up till 9 years of age, but again, Maristelle has already been using it with pregnant women to do this. And this is just the kind of data where you can begin to get this sleep staging that we really couldn't get before. And again, this is, as I mentioned before, is particularly interesting for folks who are also interested in growth. It's the only way I got my kids to sleep you know, and they don't want to go, every kid doesn't want to go sleep. But I ended up just saying, how tall you want to be? And then they kind of incorporate that. Sometimes they just didn't want to hear it. But it really did. They ended up being 4 inches taller than me, which is what they wanted to do, so they could look down on Dad, and they do. This is one of the, I'm not advertising for this because it happens to be the one, though, of the 3 that we are now testing, or about to test, which we now have this one working in the unit, but there are 2 others to follow. Where there are dry sensors inside here, you can barely see them, but there are 7 of them inside here. All the data is collected here on this medallion, and the medallion sends the signal off via Bluetooth or Wi-Fi, depending upon which model you get. And so we can collect data overnight. Moms go home with this. This particular band is very comfortable. Moms can wear it overnight. It's washable. It's reusable. So I can use it in my, not just for moms can use it repeatedly, but we can take it and wash it and disinfect it and use it in many of our sites in the low, moderate income countries where we have to use the same device over and over again. And this is the only one I know something about the price point. For the commercial device, which is made to give parents some sort of parental reassurance, that's a whole other topic we could talk about sometime, but it's about $300. But for researchers, I think they're much more willing to share this device for a cheaper amount. Because we are interested in looking trajectories, starting here and going again all the way out here to this geriatric age of toddlers. But we want to be able to measure what we think are important phenotypes using some of the same inputs. Autonomic nervous system, EEG, non-invasive EEG. EEG we can send home with the kids, 2 leads of EEG where we can send them home at night. Putting those together in some meaningful way to again do better, not just collecting the data, putting it all together, having people who understand big data to put it all together, but also again to use that same principle for defining different interesting clusters of outcomes when these kids get up to that age here during toddlers. The last thing I want to talk about is this is the study I put in my title, so I figured I had to say something about it. Prenatal alcohol, SIDS, and stillbirth, called the Safe Passage Study, PASS, good for this. The reason we call it Safe Passage is because when we were recruiting these 12,000 maternal fetal dyads, it was a lot easier to say, would you like to be part of a Safe Passage study than this one this was designed to do, which was stillbirth and SIDS. And in fact, many women came to see it that way. In fact, we had trouble turning people away once the word got out because they got a lot of attention, not from me and my physiology group in New York, but from all of the people on the ground who collected the data, gave mothers information. We couldn't give them information about what the autonomic measures meant, etc., but they could help them answer their questions. That alone, as you already know in this group, made a big difference, I think, on some of the outcomes. So again, just us being there, but that was a welcome distraction from what would be our otherwise more pure data. Because we measured all these things. Maternal drinking patterns. The folks who did this, they did questionnaires with they know not just how much they drank, when they drank it, how much ice was in the drink, to give a much better idea of what these mothers were exposed to. And nutrition and depression and other drugs of abuse, genes or genetic material was collected. We did the autonomic measures with hearing screens and then did a follow-up at 1 year neurobehavioral assessment. We tilted all our babies to get an autonomic challenge to be able to measure what the response was to that. There were many fetal measures that were made, and over somewhere around a third of these, like 4,000 of these, had placental histology done. So again, it wasn't done online, which many folks are trying to do right now, but it was an incredible amount of data and effort, largely led by Hein Odendahl and his group, who pulled all that together. And then about over 200 of these kids died, about 130 stillbirths and about 60 of sudden infant deaths. So there's quite a few babies who met their demise, and then we could do the autopsy. So these are the things that I've been measuring. I'm not going to go into too many more of them other than to say that if you looked at some of the measures, and there's many more than this, as it happens, fetal sex, which I guess because I use the word sex, I put my finger over it, is one of the more important things in describing what's happening here. This happens to be in the, these are, what the hell is this, Niccolo? These are the heart rate means after we put all the other measures in here, whether moms were depressed here or not depressed, but then there were the difference in males and females, males in blue, females in red. There is a difference based on sex on the effects of these exposures. That probably isn't novel to a lot of people in this room, but many are. And we got the same thing when we were looking at smoking. Again, whether it was no smoking or smoking, there was a differential effect out here whether you were male or a female. Again, then we can start looking at things by not just weeks, but rather each week of gestational age. We start seeing very big differences as a function of gestational age, and this was done with in overall heart rate variability. But we can start doing things in other measures of heart rate variability. This happens to be means, but we're showing the difference by whether they're in the active sleep state or quiet sleep state, active, quiet, and then we see differences based on sex as well. So you can see it here, but there are distinct differences by sex of the infant. And here's a bar graph showing some of that. Differences in RMSSD. We didn't see any at 20 to 22 weeks. We still didn't see a significant difference in males and females at this age, but clearly it went up. And at 34 to 38 weeks, this is when we began to see a statistically significant difference where males, surprisingly to us, looked more mature. It's probably one of the few things we've seen where males show a little bit of an edge in being more mature. This was it. And again, we can start seeing this during the fetal period, and it's even more striking as a newborn. And again, this is just looking at the same story when you're looking at males versus females, but then you can look at fetal heart rate variability beat to beat. In quiet sleep, you don't see the change, and in active sleep, you do see the change. So again, you have to know what you're asking, when you're asking it, at what age you're asking it. And this is my last slide to show that we can begin to be putting all these things together. And I really hope to see this for an opportunity for collaboration and sharing if there is any interest. The Safe Passage study had 12,000 kids. Now 7,000 are being followed up in South Africa, 5,000 in the Dakotas. The ones in South Dakota are part of that big national study I mentioned to you. The ones in South Africa are by the European Union Autism Consortium. Many of them now we're working with the Gates Foundation, who now care about growth above the neck. It was all about growth and stunting and other things before, but having a measurement of brain growth is really, really important. We're looking at gestational diabetes in a few different cohorts. There's a big study just started in the States because of the opioid epidemic, so there's a ton of money to deal with it. And so they've never imaged thousands of kids the same way over multiple times. So repeated measures of imaging, fetal and postnatal, not just MRI, but EEG, autonomic measures, maybe NIRS. All of these things are going to be done in 10,000 fetuses and infants as part of this study. So we'll have 80% of them will be so-called normal, or at least not exposed to opioids. And then the Human Placental Project with our folks in King's College, where our measures that have been talked about here today are used along with the MRI measures they're looking at now and ultrasound measures of placental function. So because that isn't available everywhere, and we think that some of our other metrics of heart rate variability are going to be tied to these other more interesting measures. And I think that was it. So thank you very much for hanging in there. I probably went over my time, didn't I? And too much stuff. Okay.
Perfect. But we do have some time, do we, for a couple of questions? Yeah. Okay.
For those of you who have managed to, I was talking about sleep. That's the worst thing I could do. And I showed a picture of a baby yawning. I was looking around to see, but I didn't. Yes.
Thank you. Can you tell us a little more how you were detecting the sleep state?
Oh, yeah. Yes, and I think I refer you to the articles by Ben Hein and Nyhaus and Prechtel, because they are the folks that really used simultaneous ultrasound measures along with heart rate tracing patterns to kind of divide things in about 4 or 5 categories. Where and it was really pretty clear. It's the same thing we saw in preterms, where you'd see certain patterns, minimal accelerations were quiet sleep, patterns that lasted a little bit longer based on the amplitude and the duration of the accelerations were in active sleep. The awake ones were very clearly to see because of these lengthier body movements. So they kind of validated all of that. We just stole the idea and used it for our measurement. And so we now are using, right, for this group, we had to do this visually and then have another coder go along and make the same reliability assessments. But now we're working on, like everybody else, the black boxes of machine learning to do a better job of automating the whole process.
I have a question about your experience looking at maternal and fetal data at the same time with regard to sleep staging.
Yeah.
Can you share some insights?
I can share the fact that because of Niccolo, we've now got a wonderful colleague who actually has been really interested in that. Do you want to say a quick thing about who's doing that? And
Oh, so yeah, we actually started to collaborate with Ricardo Barbieri.
a little louder and up, yeah.
Oh, okay. With Ricardo Barbieri, is a professor at Politecnico, and the idea is to try use more sophisticated way of trying mimicking the behavior of both moms and fetal. The idea is to use like a point process, so you can derive both a prediction in real time of both rate patterns, but also try to predict on a more real time scale some autonomic nervous system parameters to be able to see if, for example, the changes of maternal R rate are then reflected on the fetal, or there's like bidirectional interaction between the two subjects, let's say.
And knowing it won't be easy because, as you saw, the maternal position changes, the time of day, big circadian ultradian rhythms, and sleep state. But I think that's why we need the help of other people who are used to looking at these signals.
Yeah, the main pitfall is like combining 4 maternal position, 4 sleep states, and then the number really drops when you try to find, like, I don't know, 20-minute segments in which you want to try to infer some interaction between the two.
Not here.
Oh, Martin was asking if we were using Monica device for that.
No, we aren't. Yeah, we needed a device where we can do something for about $5 a patient, and that's what we can't do anymore. But we can talk more about the people here who actually deal with that product. So. Barry.
Very nice speech. Clearly, one of the influences, and this increases as gestation advances, is uterine contractions.
Right.
And you need, in a sense, you really do need to be measuring or understanding when those are occurring.
I couldn't agree more.
They are clearly influencing the interaction, the time, the time response of the fetus.
And I think I'm allowed to say the other company that's sending us devices is called Bloom Life, and they have their contraction monitor is really pretty good, the one they sent home, and they want to extend it to get heart rate. Because I didn't want to put 5 different monitors on, but if I could put one that's going to do a few different things, that's one of them. And then there's another device. If you want to look at a cool website, it's called Level 42. I should know that. That's the Hitchhiker's Guide to the Galaxy answer to the meaning of life. It was in the computer after 1,000 years said 42 was the answer. Well, anyway, this guy does artificial intelligence. It's called Level 42, and that's what he's going to be doing, just as you suggested.
And the belts that you showed, the second slide.
Yeah.
So what sort of technology do they use for the fetal heart rate?
Oh, that belt I showed was not fetal. That was just getting maternal. Oh, the big belt, Owlet. Yeah. Oh, yeah, the Owlet one. Yes. Yep. Yeah. They have 7 sensors that are picking up pretty much the signals look exactly the same as the ones we saw earlier today before they were smoothed and anything was done with them. And again, we're happy to be working just with their device, we're happy to be working with their device because we know we can get the raw data and see, well, wait a minute, are they really marking what they say they're marking? And they're allowing us to go through there and do that. Otherwise, we wouldn't feel comfortable about using it.
But they use the Doppler, don't they? I mean,
no, they don't.
Pretty sure they do use
Well, they don't with this device, the Owlet people. No. But using Doppler with this together, I think could really add all sorts of things, but not overnight.
Can I follow up with a
Sure.
question on the same thing? Because we all got interested immediately in that belt. And
Yeah.
so were you just saying that you're getting the raw data from them in the sense the raw data you were getting from Monica, I know the AN24 device, it was already separated. You get fetal heart rate, you get maternal heart rate, and they look like heart rate.
Yeah.
When you say raw data, do you get...
I should amend that. Right now we get, after they've process the signal a little bit, but they are willing to share their raw data to say, this is how we did it. Do you think you can do better? Because we're not trying to make any money out of this. We want them to make a better device, and they want to make a better device. So I believe if you got in contact with them, and I'd be happy you could say, I sent you, and if they say no, so don't tell them I sent you. No, I know anyway, but I do think they might be amenable to that. And I bet the Bloom Life people would be too, and as well as the level 42 people too.
Okay. Do we have to finish now? Yep. Thank you very much, William.
Thanks very much. Appreciate it.
Yes. So thank you.
I don't get, get to do this, right?
We have children.
So for the people who staying for the scavenger hunts, we are going to divide all of you